Can you hear me? The mic is working, or? Okay, thanks. Thanks for coming. I know you have options to go to, I don't know, like probably 10 other sessions. So hopefully you're in the right room. Saw the title. If you are still in the right room, I'm glad. Welcome to BITS. This is my first time in person. I presented virtually last year. And I feel a little bit overwhelmed, with the hosts here, sponsors, organizers, and helpers, right? So, these two gentlemen is helping me, so thanks to them. I'm also trying to help in few sessions. So let's get going. As you see that I put my bio in a small print purposely, I don't expect you to read this because we don't have time. But I want you to take a note of my contacts. And I'm still a little bit old style. If anybody want, I still carry cards. So, this is a 50-minute pact. I might not be able to answer all your questions. I might go quicker. If you didn't catch anything, you want to reach out to me, take a card, or just remember the word SQL worldwide. If you search it in Google, you'll find me. And I can promise you that you'll get an answer in probably 72 hours. And sometimes I don't know the answer, actually. But the advantage is I know some smart people. So I reach out to them, I get the answer, I send it back to you. Sometimes I give the reference, sometimes I take the credit. So you can try. It can go either way. I do run a lot. We ran this morning, few of us, so that's fun. And feedback. So this is important for me because, like I said, I'm first time at SQL Bits. Don't tell me that you did not like my session. No, you can say that, but tell me why, right? Because I go home, I read, you said you did not like my session, I didn't do a good job. I can take that. I have 3 children. So you can be as raw as possible. I'm not going to cry because, I have 3 children and I have twins, so I get that a lot. I have one in college, so you can imagine what I get. So you can give me any raw, but please tell me that slide or this point so I can improve, right? So, and I'll show you again at the end. And that's about it. Oh, question and answer. So raise your hand anytime, because I think this high-tech question thing didn't work yesterday very good with the app. It didn't show up. It went to the next session because I volunteered in few rooms. So raise your hand and we'll get questions because that's important. Right? If you have a question, don't think it's silly. I'm sure 10 other people have it. They just don't want to raise their hand. So raise your hand, ask question. We don't need to go through all slides. You can download this from my GitHub repo once I upload. So we'd rather talk, answer your question, get into a discussion. Fair enough? Great. So anytime I give a talk, right, why should you talk to this talk, right? There's 10 other talk going on, maybe Bob Ward is speaking, people coming to listen to me, right? There has to be a reason, right? So first let's talk about in very brief. And I will have few more slides that will lead us to checkpoint. Because if you don't understand the few other basic concepts, if I start talking about checkpoint directly, it won't make sense. So first 10, 15 minutes probably will be a warm-up that will lead us to checkpoint. I have 2 demos. And at the end, I'll also give you a reference slide. There's about probably 10 white papers that I'm going to refer to so that you can go back and read into more details. Checkpoint does 3 things. And I will touch upon some of these in future slides. First thing it does is we call it durability. And this is one of the 4 basic properties of most of the relational databases. And I'll go into details. It does the crash recovery very quickly. And what do I mean by crash recovery? If you've been working with database, hardware, you probably have seen. Even if you're in Azure, don't think that you are immune to this. In fact, in UK, region 2019 or 2017, bunch of people were out for 16 hours, some minutes. I have another talk, I know this for sure. So if suddenly someone takes the plug out, what happens, right? Checkpoint helps in that. The other thing it does that people don't think about, it actually helps with your I/O. And I'll talk about this more. So Checkpoint helps you bundle your I/O, do 1 writes to your disk, and it commits, it guarantees that your data is going to remain safe. And we'll go into details. I'm just trying to, warm up, give you a preview. How does it does those 3 things, right? Basically, with these 3 pointers. And I'm not going to read this. You can read, or you can get the slide. So it keeps a pointer. And that pointer gets into the boot page of a database, and it keeps a marker that I'm done up to this point. If someone pull the plug at this time, start looking from this pointer, what do you have to roll back, or what do you have to, we call it undo and redo. So it keeps a good point. Whatever is in your log, use that point and go through the logs for the recovery. So that's pretty much what is checkpoint, how does it do it, right? You can all go now. No. So we'll go into details of all this. But as I said, before we go into checkpoint, there are a few things that I want you to know. And I talked about durability, that's the fourth property. So this is, we call it ACID property. I don't know how much you are into, if you go to database 101 or even probably most of the computer science undergrad programs will have some database class, they will teach you this. And there is some history to it. I have it in the notes. I'm not going to read all this. But we'll talk about this a little bit more. And I'll try to be not very technical when I explain this. The first one is atomicity. So imagine, if you're a lot younger than me, this is probably foreign to you, that you transfer money to somebody's account, right? You say, this is Daniel's account. Daniel's sitting here. Give Daniel $100 from my account, right? What will happen if money is taken out from my account before it gets deposited to Daniel? Something happened, because it's in one transaction, right? We have two statements. Withdraw from my account $100, deposit to Daniel's account. So they took my money, did not deposit, and the server crashed. Daniel is not happy. Am I happy? No. Where is my $100? Nobody has it. So database have to guarantee that in a transaction, either everything gets done or nothing gets done, right? If the server crashed, my money should go back. That's what we call it rollback. So that's guaranteed by atomicity. And this can be a one session just talking about these four properties. So I'm just going to go quickly. Consistency. This is the most confusing one. So SQL Server, or probably pretty much any database, you have constraints, right? You have foreign key constraints, you have primary key, you have unique key, you have default values, right? That this column only, or a range of values, that this column can only have 1 to 100. And these are there for a reason, right? So you make sure the data is accurate. There you have restrictions. You honor those. Isolation. This is also very important. One of our friend, Eric in Canada, he has a blog post. He said, don't look at my work, right? If I'm doing something till I'm done, don't look at me, right? So if I'm doing a 1,000-row update in one batch or in one transaction, if I have done 500 of those and something happened, I don't want you to see that 500 till I commit up to the 1,000. Because if something happened, I might roll back. So if I let you look at my change data, and if I roll back, what is going to happen? You saw something, but that rolled back. Not good. And the way SQL Server does this by locking mechanism. It's a fascinating stuff, right? How SQL Server do lock and latch and protect all this. Because in a database, you are not just the one, right? If you are in a bank, are you the only one doing one transaction? No. If you are booking tickets from British Airways, you are not the only customer. What happened if I'm getting a seat and I'm not done yet, and somebody else can look at that seat is available? What's going to happen? It's a total chaos. So with isolation, SQL Server does it, but there is one called read uncommitted. If you use that, please be careful. Make sure you know what you are doing, right? The other three I'm not going to talk about. The other three are pretty safe. Read uncommitted, don't use it loosely. You will regret it someday. And I talked about durability at the end, right? At the beginning, that this is the one that's related to checkpoint. I'll tell you a true story. In my previous job, I worked for healthcare. My boss quit just for one transaction. He literally resigned. It's a healthcare company. So you submit a transaction, and you get the acknowledgement back that this was committed. As a database professional, I don't care, you can call yourself DBA, data operations engineer, data engineer, whatever, architect. Our job is the customer submitted something, it got committed, they got the acknowledgement. We cannot go and tell them the server crashed, the storage failed. No. Once a customer get committed, commit back, you have to have that transaction. This is guaranteed. As a database property, durability does that. So checkpoint helps in the durability with a couple of other things. Any question? No. There's another concept, clean versus dirty page. This is also related to checkpoint. So what's the clean page? So as you know, for performance reason, SQL Server do not change any data in the disk itself, right? Anything we have to do, read, write, update, delete, the page has to be fetched from the disk to the memory. Once we fetch a page, then we have to write, right? If you want to do update, you have to change that page. Now that page does not get written back to the disk every time. So imagine if you put an update statement for just 1,000 rows. Would you like that you update one row, write the page to the disk, read again, update another row, write to the disk, and bring it back? How long that's going to take? Not practical. We read the pages, do 1,000 update, then we write it back to the disk. So as long as it's not getting written, we call that a dirty page in the buffer. And I'll show you in the demo how you can track your clean page and dirty page. And there are other reasons to track your, what's in the buffer. If you have, memory pressure, if you are seeing, there are other symptoms that you will be tracking what's in your buffer. Normally in your day-to-day operation, you don't care, right? Unless you get memory pressure or you're getting some other word types, you don't care. But there are times that you would say, and there are now DMVs that you can actually track in your buffer what pages, what objects, how many are dirty, how many are clean. You can all see that, and I'll show you in the demo. There can be also other way you can see dirty page. So checkpoint write dirty pages back to the disk. But checkpoint doesn't evict your page. There are other processes that I'll talk about, like a lazy writer. It will actually evict your page from the buffer because it has to maintain a certain amount of free memory in the buffer. But checkpoint never evict your page. So that's a misconception many people has, that in a checkpoint, when you write to the disk, that page get evicted from memory. No. Because if you're going to do a subsequent read from the same page, SQL Server now have to fetch it from the disk again, so it's extra work. So the engine is clever enough. It says, I just have to make sure that these changes go to the disk, but I do not have to evict the page. So I have a page, I wrote some stuff, I made it change, it's dirty, I wrote it back to the disk, now it's a clean page. But if someone issue an update on the same page again, I make changes again, it becomes dirty again. Right? And the last concept is write-ahead logging. Then we'll go back to checkpoint. And this is absolutely important to understand what's a checkpoint. So I said that if you're doing a bunch of updates, and SQL Server is not going to write it back to the disk every time, right? So what happened if I gave an example of 1,000 rows. Someone says, update this 1,000 rows. You did 500, and SQL Server crashed, right? Or someone issued a checkpoint, and you're not done yet. How does SQL Server know that this transaction did not get committed? Before any checkpoint or a page get written to the disk, SQL Server have to make sure that all the transaction logs get flushed to the disk. And this is another misconception, that people think that during the checkpoint, only the committed transactions get flushed. No. Any transaction log up to that point, doesn't matter it got committed, doesn't get committed, because your transaction logs are all sparsed, right? It's not that you have a fixed place to write your transaction log. This session is writing here, this person is writing here. No, it's all just being written serially. So if 1,000 people are working in a database against a database, and say like 900 people committed, 100 people's transaction is still not committed, there is a checkpoint, and then there is a crash, SQL Server will find that point and see that there is no commit for that transaction, it will roll back. And I'll show this in the demo, right? That's how SQL Server can guarantee that if a transaction is committed, it is there. If a transaction has not been committed, it's partially done, that I can roll back, right? It sees that I have a begin transaction, and it doesn't see that I have a corresponding commit transaction. Even though we don't type every time begin tran, commit tran, right? You can do that. You can do it explicitly, but SQL Server implicitly does that for us for any transaction that we submit. So if I'm half done, SQL Server doesn't see a commit related to my transaction. It will go and slowly roll back. And I'll try to show this in the demo. And I'll also have another slide. Let's see how does it do it. So just imagine, right? We are not doing this. So I said, update this 1 million rows. It will begin a transaction. It will fetch the page. If the page is already in memory, it doesn't need to fetch the page. If the page is not in memory, SQL Server is going to fetch that page from the disk to the memory. Then it goes for lock and latch, the third bullet. And what's the latch? The latch is a lightweight lock. Latch only required for a very short period of time when the physical structure being changed in memory. Right? That's the only time it holds a latch. But the locks happen as soon as you pull it from the disk to the memory. Then it generates a log. Look at this. So it did not change the page, right? But first it has to create a log. And then in that page, that data page, in the header, every data page header has a log sequence number. It has to update that. That is when the rollback happens, SQL Server quickly knows that these pages, I do not have to touch anything, but these pages, I have to redo or undo. So every data page has the last log sequence number that the page was changed. So then it updates the LSN page, and then it makes the change in the page, and it becomes dirty that I showed you before. Because now I have a page in the memory. It's not the same as what was in the disk. Now I call this page as a dirty page. And there's also a bit. It keeps track that am I a dirty page? Am I a clean page? As soon as the change is done, it will release the latch. But notice that I didn't say that it released the lock. It did not release the lock, right? And now some of you might differ with me based on the isolation level. And as I said, if we go into that route, we won't be talking about checkpoint. We'll just be talking about the isolation level for a whole 50 minutes. So that can be a different discussion. So we release the latch. And then, because I said we are going to update 1 million records, so probably 1 million record isn't going to fit in 8K page, it's going to fetch the next page and do the same. When all 1 million update is done, it is going to flush those records to the log first. All the log records, to the disk, not to the log, Yes, the log records can stay in the buffer. Sometimes people get surprised when I say that. Once my log records are flashed, then I'm going to do a commit transaction, and then I'm going to release the lock. Right? Before I commit the transaction, if anything happens, SQL Server will know because I updated some of the LSNs, right? And it will see that my begin transaction, but it will not see my commit transaction. So it will go back and find all the log records with the transaction and will replace it with the previous value and roll back that update. Make sense? Any question? You can raise your hand. There's a mic here. They will take it to you. Yes, go ahead.
Files reside. My question is, read the flush logs. If the underlying volume where the log files reside fills, what happens to the flush logs operation in that scenario?
Yeah, so the question, very good question. If my log drive is full, what happened to flushing of logs? It cannot. So that's why when our log is full, what happens to the database? Stops, right? It goes to a different state because SQL Server said, I cannot take anything else, right? Because I cannot track it anymore. So I won't let you make any more changes till you free up the space. I'm done. I'm stuck. It's a red light. Pretty much red light, right? Or not pretty much, it's red light. Stop. Do not move. If you move, you get a ticket. As simple as that. Because it has to flush the logs. Otherwise, I cannot roll back, roll forward. I cannot guarantee. The ACID properties has to be honored. Like I said, as a transaction is committed, it has to be there. Customer doesn't want to know your story. I work for an investment management firm. Now I work in healthcare. These people, customers don't care. You're sitting in the boat, in passive. You don't see, how much money I made today, right? You tell them, we don't know where your money is. You can give it back to me. I'll send it to somebody else. So, in my previous slide, right, you see this, all this. Did you forget to flush dirty pages, right? I didn't have a bullet point to write the pages back to the disk, right? In my previous slide, I did not say that. I only made the update. I flushed the logs. I committed. Did I say that I'm going to write this back to the disk? I did not. So once I committed, because I didn't do a checkpoint. Now, once I committed, if the server fails, power goes off, what is going to happen? When it comes up, it knows the LSN from the boot page is going to redo this update and change the pages it'll call it from the disk, but make the changes. So my change is permanent. Then it will make it permanent. OK. We are getting to the checkpoint. There are two other processes which I'm not going to go into details for time. Also does similar stuff. So I just want to mention it because you will hear about this when you read about checkpoint. One is called lazy writer, one is called eager writer, and the other one is a checkpoint, of course. So I'll go very quickly. Lazy writer's job is to keep enough free space in the buffer. And checkpoint only works with the dirty pages, but lazy writer can evict, clean, or dirty page, both. And if lazy writer wants to evict a dirty page from the buffer, it has to do the exactly same what checkpoint does. It has to make sure the logs are flushed, and then only it can push the dirty page to the disk. And why lazy writer does it? Because it has to make sure there's certain amount of memory is free all the time for other operations to work, right? So it does that. There's another process called eager writer. Have you heard of bulk insert? Select into? Why these operations are so quick, right? So to make it faster, SQL Server has to do something different. It actually brings pages and flushes pages at the same time. It doesn't wait for the full commit. Even before the commit, eager writer can flush the pages to the disk. But anytime a dirty page, doesn't matter what process, get evicted or get flushed to the disk, it has to do the same process as I said. Has to flush the logs, has to keep track of what is getting back to the disk, so it can do the redo and undo. So that's enough. So now we are back to checkpoint, right? Good. Took me a little bit of time. So what really happens during a checkpoint? First, it has to also create a log record that I'm beginning a checkpoint. And I'll show this in the demo. Checkpoint has to have a log record for itself. Log records written to disk, we talked about it. Dirty data pages are written to disk after that. LSN of checkpoint record in boot disk. This is new in SQL 2012. I'm sure some of you are running 2008. Don't raise your hand. I don't want to shame anyone, but I know some of you are running. If you're in 2008, some of my demo might confuse you, but run it in your newer instance. Yeah. Because recorded in boot page is a new in 2012. So boot page is the number 9 page, file number 1 of every database. It keeps track of the last checkpoint. That's very important. That's when the crash recovery happens, it looks at the boot page. It knows that I'm good before that. I just have to worry about what happened after this. If your boot page is corrupted, your database will not come up. Right? If it's me, I'll probably start restoring. Call Microsoft, Paul Randall, he will probably open it in a hex editor, right? He will probably do some stuff. I'm not that cool. I don't try that. I open a case, or I get from the logs whatever I can recover, right, from my backup. If you're in a simple recovery, what happens? I'm not going to go into details. There's something called VLF, virtual log files. Our log files get sliced into VLF for different reasons. It marks your VLFs as inactive, means I can use it. Because your log file is a circular file, right? Like the gentleman asked a question. If you come to the pointer, there's nothing else is free, you are stuck. Your log file is full. So if you're in a simple recovery, during the checkpoint, your VLF is going to get inactive. You're going to reuse it. If you're in full recovery, even though checkpoint happens, will your VLF get marked as inactive or no? Something else needs to happen. What is that? Log backup, yes. So in simple recovery, no log backup. It says that all these things got flushed, reuse it. Full backup does not. It just mark it that I'm done. These are got recorded, but you still have to back it up. And then checkpoint ends. It also create another log record, that end of checkpoint. Any question? Yes? I'm sorry, I have to wait for the mic because this room is talking.
And if, nevertheless, whether it's a simple recovery model or another, if there's an open transaction on the VLF, it isn't marked as inactive then, is it?
If there is no, what you said? I'm sorry.
If there's an open transaction.
Oh, it depends. Because I said your logs are all parsed, right? Your logs are not. You don't get a dedicated VLF for your transaction. It's all interparsed. So up to everything in the VLF has to get committed. All the transactions that has records there. See, we all don't get our dedicated VLF. That's the problem, right? So I might be committed, but somebody else might have an open transaction who has a record in that VLF. So that VLF cannot be marked as inactive. Everything in that VLF has to get. So if you have a long-running transaction at the beginning, everybody is stuck. Everybody is in the queue, right? OK, so now I'm going to get into some changes, then we'll go to a demo. The first one is I/O size. This is, I know I didn't talk about indirect checkpoint, but I'll talk about it. I said at the beginning of the slide that there are three things, right? A durability, crash recovery, and the other thing I said is a I/O optimization to your disk, right? How SQL Server does it? It does not write every update. It bundles this, and it does one single write to the disk. Pre-2016, it was 256 KB. From 2016, now it can write in a chunk of a 1 megabyte, right? So 8 KB page, how many pages? 1,024 pages, right? So they can bundle it together and just make one write. So that's efficient instead of writing it 1,024 times. Throttle threshold. Checkpoint also continuously monitor our I/O performance. If it sees that I'm backed up, right? There's a lot of I/Os are waiting. Checkpoint will, back off a little bit. So I'm not going to be very aggressive. Also, it checks the latency of your I/O. It was 20 milliseconds. After 2016, if it sees that your I/Os are taking 50 milliseconds, checkpoint will back off a little bit. Because checkpoint is a heavy I/O intensive. I'll show that in the demo. So it will back off a little bit. It will say, SQL Server is already busy. Let me not make it worst. Right? There's a startup parameter with -k. You can look it up, books online. I've never used it. Also, you can, there's a number you can put in megabyte to control your checkpoint speed. I'm just putting this in case if you need to throttle your checkpoint, you can use that parameter. So let's go to our first demo. Very simple. You don't need to, I'll share all this with all of you. So I'm not going to read all this. I put enough comments that you'll be able to take it and follow through, just creating an empty database. I'm doing the auto-create statistics off. Please, please, please don't tell your boss I told you this. I'm just doing this for demo to keep the LSN entries at a smaller number, just for our benefit. Do not, please do this unless you know what you're doing. This is just to keep the logs. I get less record, so I can focus on what I want to show you. Please do not refer me. That will be my death. in the tech community if you do this. Especially Paul Randall will kill me if he sees me next time. Yeah. He's like, that's not what I taught you. So now you see that we did an insert, right? Maybe I shouldn't highlight that. It doesn't look good. Do you see that I created a table and I inserted one record? So where is that page right now? Huh? In memory? It's in memory, right? Is it a dirty page or a clean page? Sorry? Dirty page? Yeah, this gentleman is right. So let's look at it if he's right or wrong. So my friend Pinal Dave, I love him. I love him dearly. I didn't have to write this because I copied from him. And I put it at the top, so make sure I give him credit. I love him dearly. Trust me. Should I blow it up a little bit? Oh, gosh, no. OK, good. So what does it say? See that object name, right? I created user table. I have 2 pages. They both are dirty. But did I commit my transaction? I did. If the server crashed right now, what will happen? It will, yeah, so it will go to the disk, fetch that page again when the server comes up, and it will make this change, whatever I did. But I didn't do a checkpoint yet, because the page is in buffer. It's still dirty. So let's do a checkpoint and see what happened. Or let's see what are the records right now we see there. No, let's do a checkpoint. And it's too small. See what I said? It says the begin checkpoint, end checkpoint, right? It also has my insert rows, right? And my commit. Now if we go back to the buffer, what are we going to see? Clean page. Oh, yeah, clean page. And as I said, SQL checkpoint did not evict the page to the disk from the buffer, right? Because it doesn't need to. It's the same copy in the disk, same copy in the buffer. Because now if I do a select from the table, SQL Server doesn't have to go and do another I/O from the disk. Because I have the same copy. Why evict it? Because there's no memory pressure. It keeps it there. Yes. So there's a question from...
Yeah, so question coming virtually. What is the recommended disk block size for the log drive? Is it still 64K blocks or is 4K better?
I will, if you can answer it, send me an email, because I do not want to just give a one-line answer. It can vary, and I'm really in the time, so I don't want to, yeah. OK, so now let's do a begin tran, explicit, and not commit this. This transaction is open, right? Because we did not commit. I did explicit begin transaction. I don't know if my pointer will work. Oh, it does. So you see this begin transaction? Yeah, this begin transaction right here, right? And I do not have a commit transaction. What will happen if the server crashed right now? How does it know how to roll back? So let me zoom a little bit. You see this LSN with the begin transaction? This exact LSN is in this log record. I can show you this. Let's make a copy. Let's put it here. And let's bring that LSN. Let me bring that. It does it in a reverse order. So it's really not very obvious, but the begin tran log sequence number, you will find it in this log record. That's how SQL Server knows which one I have to roll back. And I can highlight a little bit. It does it in a reverse order, so it's really not very obvious. It's in this section right here. If you have a hex to decimal converter, you can go and do all this. So this is right here. Okay, and if I do a commit right now, and now look at log, I do not have any begin tran, end tran, and all that, right? No insert because it got committed. And I did a checkpoint. So I don't have that in the active log anymore. OK, I'm not going to do the cleanup to save some time. OK, let's go a little bit quick. So there are different kind of checkpoints. Indirect was introduced in 2012, but it's default in 2016. What does that mean? So today, if you have a SQL Server 2016, if you create a new database, it automatically gets indirect checkpoint. If you restore, even if you update the compatibility level from an older version, indirect checkpoint is turned off. You have to go and explicitly turn it on, even though you update the compatibility model, number. Automatic checkpoint, there's a setting called recovery interval. It's at a server level. So all databases get the same setting. What does this value mean? If you go to Microsoft documentation in Books Online, or now they call Learn website, it will say that SQL Server will try to keep your recovery time under a minute. But it only looks at number of log records. It has no idea how many pages it has to flash. So it doesn't know that how many pages involved with this transaction. I can have 1,000 pages or I can have a single page. It doesn't know if I have a long-running transaction that hasn't been committed. It doesn't know if my I/O subsystem takes 10 milliseconds versus 1 millisecond. It has no idea of this. So it's just an approximate value. And if you read the Books Online at the end, it literally says this is not a reliable value. Microsoft, I didn't make it up. You can go and read about it. When do you change default? Be extra careful. If you absolutely want to make sure you know what you're doing if you want to change that value. And don't go and change it from 1 minute to an hour. You will regret. Do it very, in a slow increment if you do it. SP configure, you can change it. If you go over 60 minutes, you will need the override option. Manual checkpoint. Nowadays, I recently did manual checkpoint. I had a server that has 2 terabyte memory in SQL 2019 because the buffer pool scan is serial. It's not parallel. In 2022, it does parallel buffer scan. So my failover was taking long time. So we do a checkpoint before we failover. But in old days, people will do, if you see the I/O spike like this, people will literally have manual checkpoint as a SQL agent job to smooth the I/O operation. People used to do that. And there is also something, in a checkpoint, you can put a checkpoint duration. So I was not very sure. So for this talk, I used Twitter. I asked in the SQL help hashtag, if you don't know, look it up. Do people use this? And, do you use the time? And, Aaron Bertrand, very famous MVP for a long time. Travis, they all responded. And I kind of summarized, in my notes where people use manual checkpoint. But nobody used the checkpoint duration, all the responses that I got. Internal checkpoint, you don't need to know this, but this happened behind the scene. So if your checkpoint is taking a long time, some of these operations will slow down, just so you know. All of this create a checkpoint at the end to make sure that, whatever you are backing up, it matches with the disk image. Indirect checkpoint, as I said, introduced 2012. This is a little bit better than automatic because it looks at the number of dirty pages, not just look at the number of log records. And by default, it's 60 seconds. You can play with it. And I'll try to show you in the remaining 10 minutes. And it's per database, not at an instance level. So if you have different database, you can have different values for your indirect checkpoint. So let me go to the next slide. I'm not going to talk about this slide. I put a URL here. If you want to read about this, pre-2019, probably CU5, especially in TempDB, you will see an issue that I here, non-yielding scheduler errors in your error log. Microsoft was well aware of this, and this got solved by doing some work around checkpoint. This will take me about 15 minutes if I have to explain this. I read it a few times to understand. So if you're interested, I put the URL here. Read this, how Microsoft solved this problem. And I know there are more improvements in TempDB. There was a lot of talk here yesterday and I think today. So probably some of these problems went away. But if you're in pre-2019, you might still see this issue. I think it's 2019 CU5. Monitor checkpoint. Do I monitor checkpoint? No, I do not. I'll be honest with you. But if you see an I/O spike that other workloads are getting affected, how do you eliminate that it's not due to your checkpoint? Right? Because checkpoint is heavy I/O intensive, right? It's writing all the dirty pages to the disk every time it does a checkpoint. So to eliminate that, to want to make sure that checkpoint is not the culprit, it's not the one that's making problem, you might have to monitor checkpoint. So there are a few different ways. First one is pretty much useless because it's cumulative. You really don't know which database. If you are into extended event, nice. You can those two you can use. Quick and dirty way is to the trace flag because you can turn it on, not with your startup flag, but you can turn it on for a time being. Look at that, and you can disable those. And I'll show you that. TempDB checkpoint. I put 2 blog posts because I get these questions a lot. How TempDB checkpoint works, because TempDB, we get new TempDB every time, right? Does it need to persist a crash? No. When SQL Server crashes, does anything from TempDB need to persist like other databases? No, we don't need to. So the checkpoint work a little bit different here. So I have some pointers. I also put, so before I go, so these are all the references. There's 2 TempDB references if you want to read about. Aaron Bertrand from US, he recently, in Stack Overflow, did extensive work with the indirect checkpoint. Very cool blog posts, 3 of those. If you read those, you'll be fully convinced there's no reason to not use indirect checkpoint. Nice thing. So we have 7 minutes, so let's go to the other demo. Hopefully I can finish in time. I will finish in time even I don't go through everything. So this one I set up before all of you came here. I'm using a tool called SQL Query Stress, again written by Adam Mechanic. Now it's open source in GitHub. It's a cool, if you have a single store proc, you want to do performance test, you want to make some change, you can run it from any number of threads, any number of iteration, you can get the runtime. Very cool. I use it all the time for some perf testing. So I'm running this. And let me show you what I'm running. So all this I'm already set up. I have comments. I'm not going to go through this. Pretty much is doing an insert update from 20 threads against a database. That's all it's doing. And let me make this big. Let me scale this. OK. So we'll come back to this. Before we do this, I talked about trace flag, right? So 3605, if you have to send anything to your error log, it's a generic trace flag. Let's turn on 3502 and see what happened. I'm going to recycle error log so it's easy for you to see. And now read the error log. Because I'm continuously doing insert and update from 20 threads, we should get checkpoints. So as you can see here, with this trace flag, you can see in your log file when the checkpoint starts. in what database. It gives you the database ID, and it says the end checkpoint. It doesn't tell me how many pages, how many megabytes got written to the disk, and how much time it took. So again, if I have a problem with my I/O, I don't know really if it's due to the checkpoint, right? Because it's only telling me checkpoint begin, checkpoint end, doesn't give me any details. And there's another trace flag, 3504. If you turn that on, recycle error log again. If we keep reading right now, we should see a little bit more info. Look at this line. Oh, no, go back. I don't want you now. See that? Now you get a little bit more details, right? How many dirty pages, how many milliseconds, which database, right? So if you know your baseline, you suddenly see this number went up, and people are complaining that our writes are taking long time. I'm in the queue. You know that this is causing the problem. You can know the exact time from the error log up to the millisecond, right? Make sense? So this is one way. I'm not going to show the extended event. If you Google it, you can get a definition, I'm sure. A lot of people wrote that. I'm going to turn off these trace flags. I normally don't keep this on unless I'm looking at this. Now, let's see how this looks like. So you see these red lines, the big red lines, the spikes? Those are my writes. And those are the checkpoints. If you see that people are complaining at certain interval, they see that, OK, my stuff are good, but every few seconds I'm getting a bad response, and that coincides with your checkpoint, then you know that why it's happening, right? Because I'm now, I'm hammering this database. So let's do one thing. Its default is 60 seconds, right? For the indirect checkpoint, let's change it to 15 seconds and see how the graph looks like. So I'm changing the target recovery time to, oh, I'm in the wrong database. No. Oh, no, I'm in the right one. OK. OK, so we did that. Let's see for graphs. See those big spike, and now look at the red line. I'm going to see more frequent flush, but not the big one, right? Because those big one, people are complaining to me that their commit time is getting a little bit longer. Now look at the red line, because I'm saying do it more frequently. I'm OK with it. Do it more, but do it in a shorter number of pages. Any question? Yes, Daniel.
Fair to say that you're trading I/O for latency?
You are saying, am I trading I/O for latency? Eventually I'm doing the same I/O, but I'm spreading it out. I'm saying it write more frequently to the disk, right? Do more checkpoints, so you have a smaller number of pages to write, instead of doing it less frequent, but doing it in a big number.
But why wouldn't the default then be like all the time?
Oh, because
How frequent is that? So you want to batch them in order to reduce or to improve the I/O?
yeah, it can go both ways, right? It depends on your workload. Am I going to do this every time? Probably no. But if my application is suffering on those times when I'm doing those big checkpoints, I might say, I'm going to break this into 10, and I'm going to do it in a smaller chunk. If you have that situation, right? I might not do it. I don't do it every day. But I'm just showing you a way. If people are complaining with I/O, and you have proved that it's due to your checkpoint, what can you do? If we go the other way right now, because it's in 15 seconds, I have also in the code, I only have a minute, but I'm just going to show you. You can also test this. You'll get this code. If I now say, do it every 2 minutes instead of a minute, now you will see that I'm going to get a lot bigger spike, but less frequent, right? Would I do it? Not do it? I don't know. I'm just showing everyone a way, if I have that situation, how I can mitigate, right? So now you will see very soon. It's going to take some time. You will see a lot bigger spike, right? So let's wrap this up. Oh, dear. Okay. So done the demo. You've seen this. So these are all URL. If you click, it takes you to there. I know you don't see the URL because it looks ugly. My contacts again, like I said, I went very quick. I know that. If you have question, follow up, I'll go to smart people, get the answer, give it back to you, and take the credit. Please, 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 I'm requesting you, because I'm first time in person here. I'm going to come back next year, do a better job. If you can give me a feedback, what you like, why you didn't like, or what you didn't like and why you didn't like, I would appreciate that. And thank you very much. Enjoy the rest of today and tomorrow.